Welcome to the solution video for the Soda Machine Interfaces Challenge. Let's go right to Visual Studio. We're going to create a new project to get started. And we're going to start with a class library. So let's just search for a library in here. And we'll choose a class library of a .NET Standard type. Okay, that way we can use it across all different platforms. This is the default library to create unless you have a specific reason why you want something else. A .NET Standard is the way to go. All right, so .NET Standard, hit Next. And let's call this Soda Machine Library. And we'll call the solution name Soda Machine App. We're creating a class library because that's where our interfaces will go. So hit Create. And once this is created, what we'll do is we will delete class 1. Get rid of that. And we're going to add some interfaces. Okay. So let's create a folder first. We're going to call this, let's call it Logic. I guess that's probably a good term for it. This is going to be all of our top end or our high level logic that our user interfaces will talk to. So this is our logic. Inside here, we're going to add an interface. So new item, and we'll say interface. And there's an interface. And we're going to call this, start with a capital I, that's the convention. Let's call it Soda Machine Logic. All right, that's pretty clear. It's a little bit wordy, but it's not bad. We'll make it public. And now we're ready to start creating content inside our interface. Now we're doing an interface first because this allows us to kind of enact our plan without code. This allows us to take our methods that we designed in our first week and put them into code, and then figure out, okay, what inputs and outputs do we need? And the reason we're going to do it in this order is because we want to think of this from the high level down to the details. And so we started at the very high level and just said, okay, what are the features of this app? We took a step further down and said, okay, what are the methods that this app probably will need at a high level? And then now we're saying, okay, what are the inputs and outputs of those methods? And that's what an interface will do for us. The next step we'll take after this will be to then create unit tests to make sure that we are validating that our methods have the correct outputs when we give it the inputs, the known inputs, okay? And so that's what we'll do next, even though all those unit tests will fail because of the fact we don't have any implementation yet. And so we'll create a bare implementation. It's just a class that has throw new not implemented exceptions. But they'll create all the tests and make sure all the tests fail. And then after that, the next lesson will be to create the methods and start making those tests pass. This is a more test-driven development style of development for our application. We create the test first and then the method to make that work. Well, we're going to create an interface before all of those so we know the inputs and outputs. Okay? So that's kind of the roadmap going towards the completion of this library. But for today, what we're going to do is take our list of methods and say, okay, what are the inputs this method should need and what are the outputs? Now, we may get some of this wrong. We may have to make some changes, and that's okay. But the key here is to get it as right as possible, to think through as much as possible and be as careful as possible about thinking it through, because that really does stretch our brain. It makes us think in a way that is all about application design. And so we finally get to the point where we're comfortable thinking about an application without having to write code. And the more we practice that, the better we'll become at it. And the better we become at it, the better we are at planning out future applications. Okay, so now what we're going to do is I've got this list of features and methods we created in the last lesson, and you should have a copy of this. So If I were you, I'd either print it out or have it on a second monitor or something like that. I've got it on the other side of my monitor so I can look at this while I am typing my interfaces. Now, one thing I just noticed, it appears like my zoom is at 90% instead of 100%. Let's change that back to 100%. Okay, so the first method, so everything's public in an interface, so therefore we just need the output. So I'm gonna type void, and I'm gonna have no parameters at first. So void list types of soda. Okay, now probably we're gonna have an input and output from this, or maybe an input. In this case, I don't think we need an input, but this structure gives us something to look at to then evaluate piece by piece instead of having an error message since we're halfway through typing something. Okay, so output. Yes, we're gonna have an output because it's gonna list the type of sodas. But inputs, probably not, because we're just gonna say what are the types of soda. Therefore, we have just the output. Well, what is the output gonna be? Well, I would assume it'd be a list. All right, so that's the first thing. So let's just call it a list of string. Again, putting a placeholder in there until I have an actual type. So what type is that? It could be a string, but I think what I'm going to do instead is create a model. And the reason why is because even though right now I just have the name of the soda to return, my thought is by creating a model to put that name into, I can always expand it later. So for example, I might later decide that different sodas cost different amounts. Well, I could put a price inside that model. Or maybe I have different soda sizes. Or maybe I want to include the dietary information of each type of soda in that model. Okay, there's a lot of different options of things I could do. Maybe I have the quantity. So it returns, okay, Coke, and we have 15 of them left in stock. All right, a lot of different possibilities that get opened up if you use a model. Now, if you use just a string, you'd have to change the type everywhere in order to add properties to it. So I'm going to create a model. So let's create a folder here called models. And inside here, I'm going to add a class, and we'll call this soda. I guess soda model is probably a good option. Make it public. And we're going to have a name. That's all we really need. And so now this is soda model, control dot to add our using statement. So list types of soda. Well, that's going to list all of the sodas. Now, what it also might do is we might list in there what slot it's in. So for example, on a soda machine, there's a couple different ways of doing this. On the really old school machines, there would be a button for each different type of soda, and you'd push that particular button and it would dispense, let's say, a Coke or a Fanta or a Sprite. Well, that's one way of doing it. The other way of doing it is you have to type in a code, let's say B3, and it releases the item in the B3 spot. So either way, there might be an indicator in this soda model saying which spot it's in. Okay, is it in slot 1? Is it in slot 2? Is it in slot B3? You know, there's all different ways we could do this. I think what we'll do for now is we'll put that in there, and we'll put it in as a string. Maybe slot occupied. Okay, so which spot is it in? All right, so that's one more property, but notice I didn't have to change anything in this logic. I just changed by adding one more property that this soda machine model or soda model has. I think that's all we need for list types of soda. So now we have money inserted. So let's start with the input. What input do we have here? And I think here we just have an amount. So we just have a monetary amount, because I'm not sure we need to go as far as to say, okay, a nickel was inserted, or a quarter was inserted, or a dollar bill. I think we just need to say, okay, this much was entered. So a dollar or 25 cents, which would be 0.25, and so on. So I don't think we have to go any further than that. Now, if you think about it, the soda machine has to determine what the item is that we inserted. So it's not like we can just say, somehow magically the user tells us, I inserted 25 cents. Otherwise, everyone would say, I inserted $1 when they put a nickel in. So there is that determination, but we're not going to go there with this application. We're going to assume that the front end will know what each value is being inserted. All right. So we're not going to worry about that. We're just going to say, okay, they inserted this much money. We're going to put it in decimal form because that's what we store monetary values inside C#. Now, return. We don't need to return anything, but what if we return how much money has been inserted total? So if you put a quarter in, that's 25 cents gets returned. You put 50 cents, another quarter in, that's 50 cents that gets returned. You put a dime in, that's 60 cents that gets returned. And it's not returning the money, it's just giving you a value back saying, here's how much money I have in storage for you. So I think that's a good idea. So this is going to be how much it returns from the inserted money, how much money is total. Now we do have a separate method coming up that's get money inserted total that will do essentially the same thing as this. But I think maybe this calls that at the end and returns the value. That way it's a convenience thing. Do we have that amount instead of having to call a separate method to see how much money we have returned? Now this might warrant, I think it does warrant, a quick code comment just to be clear. So takes in an amount and returns the total deposited so far. Just be clear as to what that is, because you only have decimal as the return type, which could be we're sending back the same value that they gave us, which would make no sense, but that could be an assumption that's made. So we want to be clear as to what this decimal is, since we're not naming it. All right, so that's money inserted. So now we have get soda price. Now remember, this is going to be called where it's just getting us back how much does each soda cost. And since we are not going to be having individual pricing, assume what it's going to do is take in a soda model, and it's going to return back, hopefully, a soda. But let's think this one through. So we're passing in a soda model. We've got the list of soda models. Here we're saying get the list of, give us the list of all the available sodas. We're going to pick one. And so it's easy enough just to send that back as a soda and say, I want this one. And then it's going to return what? how do you represent that a soda is coming out? Well, I think we could probably return just a soda model again, except for a couple of facts. First of all, we have to also return back the amount of change they get. So let's say I put $1 in, the soda is 75 cents. I'm going to get the soda, and I'm going to get a quarter. And so how do you represent that? All right, so that's one thing we have to think through. And then what happens if the request fails? Meaning there's not enough change. I put 50 cents in, the soda is 75 cents. I should not get a soda, but I should get some kind of error saying you didn't put enough money in. All right, so that's one possibility. Another is I request a soda and the soda is out of stock. What do I do then? So I've put enough money, I put 75 cents in, I ask for a Coke, and how does it tell me that no, you can't have one because there isn't one? And one thought might be, well, you don't return a Coke in this list when there's not Coke available. But that doesn't really make sense as far as a soda machine goes. Because a soda machine doesn't magically lose slots. The slot is still there, it's just that it's empty. And so we still want to represent an empty slot and not say that it disappears somehow magically. So we do want to have the ability to request a soda that's out of stock. Therefore, we have to represent that as well. So let's talk through these pieces of information. So first, we need to return back, if it was successful, we have to return back a soda. How do we do that? We could do a Boolean. So is dispensed, as in did it give you a soda? And so that'd be true if it was and false if we did not. Or we could do a soda model that is an actual soda type. So it'd say Coke and it would say what slot it came from. So that's another possibility. I think I kind of like to have the soda model and we can check to see if it's null. Now there's also a case for having both of these. And the reason why would be that we say it was dispensed is true, so then you know to check this model, and false, you know not to check that model. But I don't think that's necessary because we can return a null value here. So I think this is fine with an or null if it's not dispensed. So that's one piece of information, but the next is going to be the change. So you can get back a quarter, you can get back a nickel, you can get back a dime, or you can get back a combination of the three. So let's say you put in $1 and it was a 65-cent item. So it's 65 cents, which means that you would get back a quarter and a dime in order to get to the 35 cents change you needed. So return 2 items. So you can have 0 or more items returned as change. So I think what we need to do is we need to have a list returned. And this list would be change or list of coin, where the coin is represented by a quarter, a nickel, a dime, maybe even later a dollar coin. But a list of coin, which is 0 or more, that would be your change. Okay, I think that's what we're going to need, which means we're going to need a model here for coins. We could say a list of type decimal, but that would be a little awkward because we'd say, okay, we're returning back 0.25 and 0.1. And that doesn't make really a lot of sense when it comes to thinking about money. You think a dime and a quarter. So I think we'll have a list of coins. Because don't forget, we also, right here, has a coin inventory for change. Okay, so in make change, which is what we're doing here, we have to pull from a coin inventory. So what happens if we need 35 cents in change and there are no more quarters in inventory? Well, it would return back 3 dimes and a nickel. So it could still make the change. It would just be different change than the most ideal, which is a quarter and a dime. Do here is we're going to return back a string that's an error message. And if there's an error in that error message, then you say, okay, this is what the error was. And you can tell the user that in whatever user interface you're using. So if this SOTA model is null, then you check the error message to see what the value is, the reason why it's null. So we have 3 different values: a SOTA model, a list of coin, and a string that we need to return. We could create a model for this, something like SOTA dispensing model or something like that. But I think what we're going to do instead, I think it's most straightforward to create a tuple. A SOTA model, a list of coin, and which we don't have coin yet. We'll call it coin model, by the way. And a string, like so. And let's create a coin model real quick. Make it public. Have a name. So it's be quarter, nickel, dime, whatever the name of the coin is. And then a amount. Now 0.25, 0.10, 0.05 for quarter, dime, and nickel respectively. So there's our coin model. And so now we've got this this tuple as a return statement. Remember, a tuple returns back more, or can hold more than one item. We can even name these if we want. So SOTA, and we'll call this change, and we'll call this error message. I'm going to name these because of the fact that I want to be very clear as to what they are and what they do. All right? Okay, so let's add now the void issue full refund. And this is a tricky one because what are the inputs and outputs from this? Well, you'd think the output would be a list of coin model maybe, or just a decimal with the total amount refunded. But really I think the output is void. And I think the input is as well. And here's why. We're not keeping track of what type of coins are being inserted in the machine. We're not keeping track of what bills are there. We're just saying, okay, we've got this much money in. So when we say issue refund, what we're going to do is we're going to clear out the storage saying that we have any money from the user. And we're going to let the user interface take care of how do you redistribute the money. So I think that this stands alone as is. I don't think we need to have a mechanism for saying this is how much money you return, unless we're doing some kind of double check to make sure that the return amount is correct. But if it's not, what can we do about it? Because we're not going to then issue more coins from our SOTA machine to make up for that. We don't give money out of the inventory of our coins. We give back the same money they put in. So we don't put the money they put in into the bucket, into the repository, until after they purchase something. Until then, we hold on to it in a special place, and we just dump it back out and give it right back to them if they request a refund. Therefore, I think we leave this as is. We issue the full refund by basically just clearing out the inventory of remembering how much money was inserted. And the front end takes care of actually giving them their coins back. Okay, so that's the issue full refund. So void get money inserted total. Well, this seems obvious. We're going to return back a decimal, meaning how much money was inserted, because just like money inserted, it's the same value, which means that money inserted will probably call this get money inserted total at the end after it's taken in the money and put it into, I don't know, memory or inventory or some way of remembering that a user added money to the total. So I think that's all we need to do here. All right, so now we have void add to inventory. Now this one might push how we take care of soda model. Because how do you add to the inventory? Well, I'm assuming what you do is you pass in a soda type and you say, here's how much money we're going to put into it. The other option would be that we have basically a list of soda model, okay, which is a little confusing. But let's think this thing through. We're going to have a set of sodas. And let's look at soda real quick. So the soda model says, here's the name, which let's say Coke, and it occupies slot number 1. Well, how do you add a second Coke to slot number 1? Because we can have, 10 Cokes in slot number 1. That's how we set up a soda machine. We have a stack of cans that is ready to go for whenever one's requested out of slot 1. So how do we add one more to that slot? Do we have a count here as another property? And then we say, okay, we have 10 here, and every time you dispense one, you take one out. That's possible. The other option would be that we have a list of Cokes that are in slot 1. And so that'd be all of the items in slot 1. Then we have another list that's for slot 2 and so on. Or maybe we have one list, but we look and say, okay, here, give me all the ones that are in slot 1. And it's going to list all the Cokes. And give me all the ones in slot 2. It's going to give me all the Diet Cokes. So that's another possibility. It all depends on how you want to store these values. And I think we can store them just in a list of soda model and then use link to group them and count them and all the rest. So I don't think we have to have multiple lists or a list of a list, something like that. What that means for inventory is that we can take in a list of soda model called sodas. And what that'll be is, if they're going to add 5 Cokes to slot 1 and 3 Diet Cokes to slot 2, then they're going to put that all in one list. They're going to have 5 Cokes, and inside each one is going to say Coke and slot 1, Coke, slot 1. And then they're going to have 3 more Diet Cokes that's going to say Diet Coke and slot 2 in that one list. And then what we'll do is we'll add that to the list of values or items in our list for inventory. Now, when we return this list of soda model for types of soda, we're going to have to do a grouping inside of here, inside this method, where we say, only give me one of each type. So give me 1 Coke, 1 Diet Coke, 1, and so on as a reference for what's in that slot. Now here's the tricky bit. In theory, we could have a Diet Coke get in the Coke slot. And that happens in real life. You're filling the machine and you look away for a second, you turn back and you put the can in the slot, and you're over one too many, and you have the wrong can in the wrong slot. It happens. Well, this model will accommodate that happening. So if you said Diet Coke slot 1, it would take it, and it would dispense it as a Diet Coke from slot 1. Now, when you ask for the list of soda model, it might say Diet Coke is in slot 1 because that's the next one up. That's a possibility. And so our machine be a little bit smarter than the average in that fact, is it might say, or it should say, what the next available, next one up is. And that would be even the incorrect one if you put an incorrect one in the slot. So it's going to take in a list of soda model. Do we need to return anything? Well, we might want to see what the inventory is. But we do have a separate method for that called get inventory eventually. Actually, no, we don't. We have get coin or get current in. Nope. So I'm looking here. We have a lot of gets. We have get coin inventory. And we have get current income. We don't have anything that is get inventory on this list. So it would seem like that'd be something you'd want to know. So I think we have to add one method to our list. I'm glad we checked it. And this will be, we'll start off void, but get inventory. What's this return? It probably returns a list of sodas. That way we know what's in stock. We even know when somebody's in the wrong slot, because we'll see that if we were to look through the entire list. So I think get inventory is an important one to add to our list. All right. So now we have that is our inventory handling. We have both add to inventory and now we have get inventory. So now we have void empty money from machine. One quick note. I did not return the inventory in the add to inventory method. I did return the money inserted. I returned a total. So there's a little bit of a difference in how I'm handling things up here versus down here. But I think that when we add to inventory, we're just saying, just add it. I don't think we really care about what the inventory levels are. We're just filling the machine up. We may separately want to know that, in which case we'd ask for it. So I think there's a little bit of a different circumstance here where if I'm putting money in a machine, I want to know how much money I already have inserted. Whereas here, I don't know that I want to know that every time. All right, so empty money from machine. I don't think it takes anything in, but I think it does return something. It returns a decimal, and that would be the total amount of money from the machine. Now, obviously, physically, it's going to be doing something too, where it says, okay, you're physically emptying it into a bag or something like that. This is more of the digital equivalent, where it's going to say, okay, you just empty that. Well, here's how much money is now in that bag, which is great for a manager because then they know, okay, you should have $100 in coins in that bag. And if you come back with $50 in coins, then you know that the employee is probably taking some money or that there's a serious problem with the machine. More likely the former. Okay, so that's the empty money from machine. And then we have the get coin inventory. What should this take in? Nothing. What should this return? Probably a list of coin model. What coins do we have in the inventory? And then we have add to coin inventory. What should that take in? Well, a list of coin model coins. It shouldn't return anything though because we're just going to say, yes, we're adding to the inventory, just like we're doing up here. All right. Now, after this, so we have add to coin inventory. Now we need get current income. and that's how much money is currently in the machine. That returns back a decimal. No inputs necessary. And we have void get total income. Also no input, or no inputs, but we do have an output of type decimal, and that is going to be the total money the machine has brought in. So that should be everything we need for our interface. Now it's a pretty hefty interface. It's got quite a few methods to it. But this is the very top level of our application from a business logic perspective. So this is the business logic for our application. This is the entry point, which is going to be pretty much the only entry point for user interfaces. That's all they're going to talk to is this entry point right here. They're not going to worry about the implementation details. They're just going to say, okay, this is how you operate. Call through this interface, and that's it. But now we need another interface, and this is for our bonus challenge. So let's right-click and add a folder. And this folder is going to be called Data Access. And in here, we're going to add a new item. We're going to add an interface, and we're going to call this Data Access. Pretty clear. Make it public. Now, what this interface is all about is it's about retrieving and storing information to and from a data source. We have not talked yet about what that data source will be. We're just saying that it will be a data source. So we don't know if it's text file or MongoDB or Cosmos DB or SQL or MySQL, SQLite. Doesn't matter. This interface is the top layer of data access. Then below it, we'll create different implementations that will handle the different database types that we need to support. So let's do this. Let's create a new horizontal document group. We have at the top our interface, and then down at the bottom we have our data access, because these will feed off each other a little bit. So let's start at the top and work our way down. We might have to kind of move around in here as we put things in, because there may be more than one data access call to be made, or maybe you already have one data access call from a previous method. So we have our list types of soda, which means we need to have a way to get sodas from inventory. And to make this easier to read, I think what I'm going to do is do a naming convention that's a little more in line with what a database might do, because it might also help us group things together when it comes time to use this interface in IntelliSense. So I'm going to say soda inventory get types, like so. And that's going to give me the types of soda in my inventory. And I'll use the same list of soda model. So it's basically for this method, it'll probably be just calling this method, and that's all. Control dot for my using statement. Which, that's fine, because we're going to use the underlying database to do what it does best, which is to query data. And so we're going to query, okay, which types of soda are available? And it's going to do a query and say, okay, there's Coke, there's Diet Coke, there's Fanta, and there's Sprite. So it's going to return those 4 entries as a list. That's what databases do well, especially things like SQL Server. SQL Server, you don't want to take the job away from SQL and put it into C# to do its work for you. So if you had, let's just say we have 100 cans in inventory. You don't want to return all 100 cans if you're just asking for what are the types. Well, SQL can do that query in its sleep. I mean, that's what it's designed for. So it'll do that and return back the 5 types, or the 4 types. And that's it. So now you're returning, if you're returning 4 types instead of 100, then you're returning 96 less pieces of data across the network. That's much more efficient. So we're going to let our database do what it does best. So that's kind of a one-to-one relationship. Now, money inserted. So we're going to say void user credit. How about that? Void user credit inserted. User credit insert. And then we'll say decimal amount, like so. And I'm doing this kind of a weird naming convention because these will be the groupings. So soda inventory will have a get, we'll have a get types, we'll have a insert, all starting with soda inventory. So when you go to the IntelliSense, it'll say soda inventory, and it'll have a list of 4 different things you can do with that soda inventory. So same as user credit. So that's going to get a grouping, or think of it like a table name. Okay, so this would be a table name, user credit, and this would be an insert. We could use an underscore here to indicate table name versus type, and maybe that makes sense so that it's a little bit easier to read and a little bit easier to understand why we're doing it this way. So I typically avoid underscores in my variable names, but I think when we're talking about databases and data access, I think this makes a little more sense. Remember that code is meant to be read by humans. And so I would rather make it easier to read and understand than to make it follow a convention to the end of time. Okay, I'd rather avoid or change my convention a little bit or tweak it or just violate it slightly in order to make it easier to read and understand. So user credit insert, notice it's going to avoid. We're just going to use this to insert, which means we're going to have another one that's of type decimal that is user credit total. Now, one of the things that we don't have yet is a way to identify the user. Now, do we need that? Well, if we're going to use a desktop user interface for this, probably not, because just like a physical soda machine, if I'm putting money in, no one else is using that machine at that time. If I put money in and walk away, and somebody else walks up and uses my credit, they can do that. And that's kind of on me for walking away. So that's not a problem. But what if we create a web interface for this? In theory, we could have what could be thought of as multiple machines or multiple interfaces for the same machine running at the same time. Meaning, if I launch the web page and you launch the web page, now there's 2 different people interacting with the same machine at the same time. If I put money in, you shouldn't be able to use it. So I think what we're going to do is we're going to take in a string that identifies the user. So let's do that. And this string will be a GUID. Now I'm not going to call it a GUID, I don't think. I'm going to call it a string, but we'll store a GUID value in it. Is the kind of the way we're going to do that. And so we're going to call it user ID. And I'm just going to say it's a user ID as a string. I'm not going to create a full model for it. I'm going to do the same thing here for the user credit because now I need to know whose credit we're talking about. So this way, what will happen is when you first start interacting with a soda machine online, you'll have a GUID and you'll pass that GUID from step to step to step. And that's kind of like your state. Now, most web applications anymore are not stateful. They're stateless, which means they don't remember from call to call who you are. And you have to tell it each time. And this is how we'll tell it. And it will get the user ID and it will look up all the information about the user based upon this user ID, which will be a GUID, which is a unique string. Now, if a person walks up to a physical machine using our desktop app, you could say, then that won't be a problem. We can just give them decimal. Let's call this machine info underscore soda price. And that's it. Because maybe we have more information about the machine than just the soda price. Maybe we have the date of installation. Maybe we have the total amount of income this machine has made. That seems like other information you'd store with the machine. So I'm going to say machine info, but just get the soda price for this one. All right. So for this, we have request soda. So how do we handle this one? Well, I think we're first going to have under our soda inventory, let's have soda model, soda inventory, get soda, and pass in the soda model like so. That's going to get us a soda back from inventory that matches the requested type. If it finds one, what happens if it doesn't find one? Well, it'll return null, which is fine because that's what's going to go in this spot, either the soda or a null. Now we do need to have an error message that pops up, but where are we going to do that? In the business logic. The business logic says if it returns a null for soda model, then put an error message in here. It says soda not in inventory. Now you may say, well, what about the change? Well, again, business logic is going to say, here's how much change they get back. However, we do need to have a way to request change from the database. So let's figure this out. Let's start with a void and say coin inventory underscore get. What are we going to get? We're going to get request a number of coins, because that doesn't seem right, because what if one's not available? What happens? So I think instead what we're going to do is we're going to request a get, let's say get coins, but we're going to say a decimal coin value, and then we're also going to return back or ask for an int quantity. Okay, and this is going to return back a list of coin model. So what is it going to do? Well, we're going to say, you know what? I need 25-cent coins, and I need 2 of them. So it's going to go in and request 2 quarters from the inventory. And the inventory is going to do a lookup and say, you know what? I only have 1 quarter. Therefore, it's going to return back 1 quarter, not 2. All right. And now the business logic for request soda is going to have to say, okay, well, we needed 2 quarters. We only got 1 back. We're 25 cents short. How do we make that up? Well, we can request 2 dimes, so 10 cents, and 2 from the inventory. And it's going to get back 2 dimes. And then it's going to request 5 cents from the inventory, quantity of 1, and that's 1 nickel. And it's going to get back 1 nickel. And so then it has all the coins it needs, it adds them all up, and it sends it out here. From the get coins. Now behind the scenes, we're going to have to remove whatever coins we return, we have to remove from inventory. But that's a private method. That's not something you have to expose to the end user. All right. So I think that's all the calls we need to make in order to make request soda work correctly. Everything else should happen inside of this business logic method. All right, so issue full refund. So let's put that up here because it's next to user credit. So this would be a void user credit clear, string user ID, and that's it. And that's going to clear out their credit. That's all it's going to do in order to issue the refund. Okay, we don't have to return type on that. We're just going to say, yes, that worked. Now, obviously, if something were to happen, that'd be an exception. And that would throw an exception, and it would not return. It would instead pop that exception up the stack, and then we'd catch that. All right, so get money inserted total. This is how much money had the users inserted. Well, this would be decimal user credit total. And pass in the user ID. So that's going to get us, which I already had. Look at that. Why did I retype that? Because I already had that for the method up here that was money inserted. So I didn't have to do anything. I just had to call that again. So that's why it's helpful to group these things together, because you'd see, oh, I should have looked at my methods for user credit. Insert, clear, and total. All right, so now we have add to inventory. So we have up here soda inventory. We have get soda, and we have get types. Now what we're going to do is we're going to say void soda inventory add sodas, and pass in a list of soda model like so, and that will add those sodas to the inventory. Next, we have get inventory for soda model. So, and maybe, I wonder if we should call these add to soda inventory and get soda inventory. It seems like it's a little more clear to do that. Let's do it now before it becomes a major pain. Because we have get coin inventory, and that's a little bit different than get soda inventory, obviously. So we want to make sure that we're clear on this. So we have our get types, we have our get soda, which is a specific soda, and we have our add sodas. Now let's have our list of soda model that is soda inventory get all. That gets all these sodas in the inventory. Empty money from machine. Well, where are we storing the money in the machine? So when the user buys a soda, where do we store that? And actually, it seems like maybe if we come back up here to this request soda, it seems like maybe what we have is we have an issue where we're not getting enough information back. Maybe you should call this buy soda, and that would indicate that we're actually going to go ahead and make the purchase. Now, we're not going to call this until after we make sure that we have enough money, and that'll be on the request soda method to verify before we even call this. But if we do that, we need to do something with the user credit. So I would think that we'd return the soda model, and we'd return back the, let's call this soda, and also the decimal, which would be the change due. And what this will do is it will say, okay, we're going to buy this soda, we're going to take the user credit, and we're going to say, okay, we're going to take that much money, we're going to put it into our inventory, the amount the machine has. And then what we'll do is we will say that the user gets back a certain amount. Now here's a tricky bit. We're going to say let's say they put $1 in, and the soda is 75 cents. So they get back a quarter. We're going to tell them 0.25 is what they get back. However, behind the scenes in this buy soda, we're going to be also storing the complete user credit. Now, the only danger here is it looks like we're kind of moving our business logic from this method down into our data access. So now our data access has to know how to take care of this whole transaction. So I think I'm going to move this back to get. And we're going to take away this portion, and we're going to allow our business logic method to take care of, oops, there we go. We're going to allow our business logic method of request soda to do all these different steps instead of making the data access layer do it. So we're going to have a get soda step, but the next step is going to be the insert user credit, or to capture user credit. All right, so we're going to have a void, and we'll have user credit, and we'll say, let's call it deposit, string user ID. So we're going to take that credit and deposit it into our inventory. And the reason we're going to deposit the entire thing is because when we give back coins, so when we say get coins, and we're going to take those coins out of our inventory. So if we said deposit only the actual amount, so you put $1 in, we say only down to, I believe it's the get soda inventory. I'm not positive. We have the, nope, we're actually a couple higher than that. We've done the issue full refund, which that is right here where we clear out the credit. But now we have to get the money inserted total. So, which is that right there. So we've done that. Now add soda to inventory. Let's look at our sodas. Add soda. We've done that. So yes, we are on the get soda inventory, which that's right here. So I think we're done that as well. This is why it's helpful to mark your place in some way. I should have put a breakpoint. So empty money from machine. There's where we were. So where are we storing this money? So we have deposited the user credit. It's going to deposit somewhere, but where? I think what we do is we store that in machine info. So the machine has the current inventory and then the total. So let's do this. Let's say let's say it's a decimal. That's probably what it is. It's going to return like a value of the money being emptied. And then machine info underscore empty cash. Okay, and that's going to empty all the cash from the machine. So it's going to clear that money out. Now it's just the cash. It's not our coin inventory, which that's separate. That's for giving change. All right, so empty money from the machine. That's going to be part of the machine info. We're going to empty the cash from the machine. Okay, we're on line 31 now, which is get coin inventory. We have get coins, but that's to remove coins. Let's make that a little bit more clear. Instead of get coins, it's going to be withdraw coins. Now, it may not withdraw a coin if there's no coin to withdraw, but that's the withdraw coins. So now we're going to have a separate one, which is inventory of coins. So list coin model, and this is coin inventory underscore What do we call it when we ask for sodas? Get all. So let's do the same thing. Get all, like so. And that's now our inventory of all the coins. It doesn't remove the coins from inventory. It just tells us how much of each coin we have in inventory. So now we have add to coin inventory. So let's do a void coin inventory. I don't want to keep putting a T at the end of that. Coin inventory underscore, and what do we call it up here? We called it, we added sodas. We call it add sodas. So add coins. Man, keep putting that T there. All right, and we're going to say a list of coin model coins. Wow, that is a serious mental break for me, or mental block. For whatever reason, I can't stop putting a T at the end of coin. All right, so add to coin inventory. We're going to take our list of coins and we're going to add them to our inventory. Pretty much a one-to-one call. You're going to call this. It's almost directly going to call this with pretty much no logic. Just put it in the database. Okay, and now we're going to have our get current income. Well, that seems like it's a machine information. Decimal machine info cash on hand. Seems like it makes sense. Or, yeah, I think that's cash on hand. That's good. And then decimal machine info for the last one, total income, get total, or let's just say total income. I think that's pretty clear what that is for the machine info. So now I've kind of grouped these into what will end up being tables. Lot from this, and if you are struggling with something, you're not quite getting it, don't worry, it will click. But what I would encourage you to do is do it again. Keep doing it, typing it over and over again. Try and visualize it, draw it out. I am very much a visual person when it comes to these kind of things. So I'll get a notepad or I'll get my whiteboard and I will physically draw it out because it helps me kind of picture in my mind what's happening. What I do sometimes is I'll actually draw a user interface, a rough one, but then I'll physically touch it to go through the process. So I will simulate putting a coin in the slot because you don't just push the button and get soda. I mean, no soda machine works that way, or at least I haven't found them yet. But you have to put money in first. So seeing that machine, it makes logical sense that you don't skip over the step of putting money in the slot. Okay, so these kind of things will help you visualize what your application is going to do. The more you can make it personal and real and tangible, the easier it will be to plan this thing out. If you just try and keep this in your head and make it conceptual, or maybe even just watch what I do and not actually do it, the harder it will be and the less you will learn. So get your hands dirty and do it, okay? So go over this, make sure you understand, make sure that you're grasping the concepts. In the next lesson, we're going to take the next step along this journey, okay? Thanks for watching, and as always, I am Tim Corey.